Okay, you mentioned that you were struggling with the similarity postulates and just similarity triangles in general, and you asked me to go over a few of the questions that you missed on your quiz. I'd like to start off by just explaining that similar triangles mean that their ratios are direct or are in proportion. So let's say, for example, I have a triangle, and this is, I don't know, I'm just making it up here, 4, 8, and let's see, 17. Okay, it's not a right triangle, it's just a triangle, and I don't even know if that's a valid triangle, but we're just making numbers up so I can explain what I'm talking about. And I want to know if this side is 4 and this is 2, what would this side be? Okay, now this one I tried to make it as easy as I could, just so I could go through and explain it. And what I wanted to show you was, okay, what you do is you pick two sides from the same triangle, or even different triangles, but let's just say 4 to 8 is the same thing as 2 to 4. Okay, are those the same? Yeah, that simplifies down to 1/2. That simplifies down to 1/2. So we see those two sides are, the same, and that tells us the two triangles are similar. Okay, and I'm going to give you a few examples. I mean, this won't be the only example, but now I want to know what this side is. Okay, well, if I say, all right, 8 is to 17, the same way that 4 is to x. Okay, well, how do we solve that? We cross multiply, and we get 8x equals, and 4 times 17 is 68. Okay, so we have 68. Sorry, I lost my train of thought. And 4 times 17 is 68. So now we solve for x. To do that, we'll divide by 8, and we get x equals 8.5. And that makes sense because this is half the size, so half of 17 is 8.5. Now, there are many different ways to do that. You could say, for example, you could say, all right, well, 8 compared to 4. 8 to 4 is the same thing as 17 to x. And then you solve, and you'll get 8x equals, and 17 times 4 will also give you 68. And then when you divide, you will still get 8.5. Okay, so as you can see, as long as you're comparing the same ratio type triangles, okay, now let's go to one of your questions here that you got wrong. Okay, it says, are they similar? Basically, if those, yeah, are they similar? Well, let's look. 4 to 8, you got to compare the exact same side to side. So we know that Q is the same angle as F, okay? And we know that because in the instructions, if H equals angle R, so H and R are equal, Q and F are equal, and P and G are all equal, okay? So we know the angles are all equal. Are they similar? Okay. There are several different ways to say, but let's just go with what we were talking about. All right, well, from 1 to 3, that's 4 and 8. So we have 4 over 8, which equals 1/2. Okay, now let's try the next side. 2 to 3 is 5. 2 to 3 is 2.5. So we have to go the same order. See here, we started at 4 on top. So we're going to say this is the top triangle and this is the bottom triangle, just to keep it straight. All right, well, if that's the top triangle, that would make that 2.5 over 5. And that would also equal 1/2. And now let's look at those last side. We got 4.5 over 9. And that also equals 1/2. So we can see that all sides equal 1/2. And so we can say, yes, they are, the sides are all proportional. Okay? Because of that same reason, they all equal 1/2 when you go out and find out if they're proportional. So that's what it means by are they proportional. Okay, and that's also how you can go through and find missing sides. So let's go to another one. Are these triangles similar? Okay, well, the answer is yes, they are. And that comes from the second part of what I want to talk to you about, or what you asked about, is the postulates. How do you prove that triangles are similar? And one of the first ones is the AA theorem. Okay, there's 3 theorems: AA, SAS, and SSS. Those are the 3 that you need to use. The AA theorem states that if you have 2 angles that are the same, then the 2 triangles are similar. Okay, you don't need the 3rd angle, just the 2 works just fine. So that's angle-angle theorem. Okay, angle-angle, or AA. Okay, so that's one way to prove that 2 triangles are similar. The next way is what's called the SS theorem. Okay, the SS theorem, and that broke between 2 pages, so we'll just look at them on separate pages there. The SSS theorem means that if you have 3 sides, side, side, side. Okay, so 3 sides. If 3 sides are all proportional, then all the angles must be proportional too. So for example here, 2 to 3. Okay, now is that the same thing as 4 to 6? Absolutely. Okay, because if we just times that by 2 and times that by 2, it's the exact same proportion. Okay, so if we've got 2 of the sides, and let's just say that the 3rd one is also proportional, so let's say this is 5 and 10. Not 10. What would this be? You know, let's go back to what we're doing. Let's say that's x. I want to find out how big x is. Okay, so if one is 4 to 6, 4 to 6, then we want to compare 5 to x. Again, top, bottom. You always want to make sure you keep the ratios the same. One triangle is always on top, one triangle is always on bottom. And again, you could do 5 to 4 and x to 6, but I mean, there's lots of ways to do math. This is just the way I find it easy. Okay, so we cross multiply and we say 4x equals 30. Divide by 4, divide by 4, and we're left with x equals 30 divided by 4, which is 7.5. So that side is going to be 7.5 if that side's 5. You know, I just made it up, but you see what I'm saying, okay? If all 3 sides are proportional, then it's side theorem, okay? The 2 triangles have to be similar. Now let's go up to the last one. That would be side, angle, side. Okay, so that means what that's trying to say is if this side, there we are, if this side and that side are proportional, and we have an angle here that's the same angle as that, congruent, and this side are proportional, then that means the two triangles are similar. We don't need that third side. Okay, that third side can then go away. Well, it doesn't go away, then it wouldn't be a triangle. But you kind of get what I'm going at here. So that gives us an idea here. Okay, so let's go back to this. Here's the question: are these two triangles similar? Justify your answer. Okay, well, let's look at this. We have angle, angle, angle. Okay, if all three angles are the same, well, don't even need all three. Remember, that was number one there, angle, angle theorem. We have at least two of them. So the answer is yes, they are similar by using the angle, 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 or angle, angle similarity postulate. Okay, and then you'll want to say which angles are congruent. Okay, but let's just say, what if we didn't go with angle, angle? Well, we have a couple sides here, and we try to see, okay, 2 to 3, 2 to 3. I mean, we could go through the ratios and find out, but we're given the angles. So by angle, angle postulate, the answer is that. Okay, on this next one, it looks like I gave you points for it, but I think I made a mistake. I don't think you got it right. But let's go through that. I won't change it. My mistake is your benefit. And let's look at this. We have two triangles, one laying on top of each other. Let's bring that down so it's a little easier to see. So one triangle is on top of the other one. So here's one triangle, the one on top. Okay, and then we have the bigger one on bottom. Okay, now we need to find out what x is. We're looking for x, and we're given that they're similar triangles. Well, in your explanation, you said you used a Pythagorean theorem. Well, we're not given that they're right triangles. Okay, so that's a good guess, but it's not quite right. Unless we're told they're right triangles, it doesn't work. What we need to do is find the ratios of whether or not they're, find the ratios now that we know they're given. So we know that x is to what? Well, 2.7 is just this piece down here plus this whole thing up here. So x plus 2.7. Okay, so that's comparing this one. We're going to make this one the top triangle and this one the bottom. We're comparing this side here to that side right there. Okay, but that side we have to add the two together to get it. That's where I'm getting the plus 2.7. And then this bottom part, we're going to have the top triangle 5.0 compared to 7.4. Okay, now with those in mind, we actually have to go through and solve some algebra here. Okay, the algebra never seems to go away, does it? We're left with 7.4x, because we're just cross multiplying, and here we're left with equals 5x plus, because it's 5 times the x, and then 5 times the 2.7, and that last one is 13.5. Okay, so you see we're just doing the distributive property and multiplying the 5 times that. Okay, so now we're left with those right there, and we're saying, okay, let's go through and say, all right, we're going to subtract 5x here, subtract 5x, and we're left with 2.4x equals 13.5, and when we divide 2.4 divided by 2.4, 13.5 divided by 2.4 gives us 5.625, okay, which is what the answer is. And so we know that x is 5.625 0.25. Okay, and that's using the ratios. So the point to this whole exercise, the point to everything, is again, and I'm just gonna draw these. Okay, and I'll label them differently. We have A, B, C, D, E, and F. Okay. To find similar sides, you just find ratios, like A is to D, and that should equal B is to E, and that should equal C and F. Okay, and that's why, we end up with the equal when we do the cross multiplication. Okay, that's why we have that. All of those need to be the same. Okay, and when you don't get them the same, so let's say, like I said, I've got a 3, 5, and 10 triangle. Okay, I doubt that works, but we're just making up numbers here. And I want X and let's just say Y, Y, and let's just say that is 8. Okay, well, I can still find out what X and Y is. Okay, by doing that, I can say, all right, 10 is to 8. Okay, so we're going to make that one our top and that one our bottom. 10 is to 8 as, 3 is to X. And then we cross multiply, and we're left with 10X equals, and 8 times 3 is 24. We're going to divide by 10, and we see that X is 2.4. Okay, so X is 2.4, and we can do the same thing to find Y. We can say, all right, 10 is to 8 as 5 is to Y. Cross multiply, we get 10Y equals 40, divide by 10, and we're left with Y equals 4. So we know that Y is 4. Okay, and that's how you find the lengths, the sides of similar triangles. I hope this helps a little. It seems like as I was flipping through your test, it seems like that was where you were making the big mistakes. And here you put using the Pythagorean theorem. Again, the Pythagorean theorem only works for right triangles. Okay, only right triangles, and those are not right triangles. But we can say, all right, what are we trying to find? We need to find what T is and what Q is. T and Q. So we need to find that side and that side. Well, just like what I was doing, and I don't know where I put the paper right then, but just what I was doing on the back of that other paper. Oh, here we are. Okay, just because I have two variables doesn't mean I can't solve that. Okay, we have from angle 1 to angle 2 is 6. So we're going to say this is the top and that's the bottom. So from angle 1 to 2 is 10. See how I'm just counting 1 to 2 and then getting that number? Okay, it just makes it easier. So we have 6 over 10 equals 1 to 3. 1 to 3. Okay, so we can find Q right here. Our Q is on top and 12.5 is on bottom, because remember our top and our bottom, Q and 12.5. Let's solve it. We have 10Q and I'm going to use a calculator and find that 6 times 12.5 is 75. Okay, we're going to divide by 10. Divide by 10. We see that Q equals 7.5. Okay, so that is 7.5, and we can use that now if we want, but we don't need to. We already have the 6 over 10. So going up here, I'm just going to do that again. 6 over 10 is 2, and where's t? T is going from 2 to 3, so 2 to 3, so 4.5 over t. Cross multiply. 10 times 4.5 is 45, and then we have 6t. Divide by 6, and we see that t equals 7.5. Okay, and that's how you find the lengths of the sides. I know this is a lot, and this was in a setting where you weren't able to ask questions, and I do apologize about that. If you have more questions or specific questions, please email them to me, and I'll do more videos, or we'll set up a time to chat. You know, we'll figure something out. I want to make sure you're comfortable with this. So, and you can always go to live chat. Live chat is available 24/7. There's math teachers there to help you. So please let me know if you have any more questions.